Great, thank you. So hi, everybody. Thanks for having me here today. My name is John O'Reilly, and I'm a software engineer at Neat. And so the plan for today is to demonstrate the building out of a basic Android and iOS app that uses the same shared Kotlin Multiplatform code and uses declarative UI frameworks such as Jetpack Compose or SwiftUI, for example. And hopefully, in the process, we'll get a sense for really what I feel is a very compelling combination these technologies are together. So I have a few slides to start off just to give some background, and then we'll dive into code after that. So just a quick slide to show where I am. I'm talking here from Galway in west of Ireland, the very western edge of Europe. This is what at least Google tells me how I say hi in Romanian, so I hope I've got that correct and I haven't just offended everybody. So what we're going to cover today, as I mentioned, we're going to build a basic Android and iOS app. We'll use the same shared Kotlin Multiplatform non-UI code. And critically, for the UI view model component on Android and iOS, we're going to use the best of breed technologies that are available on those platforms. We're going to use Jetpack, Compose, Kotlin, Android architecture components on Android, and iOS, view model using, SwiftUI, Swift combined for iOS. So if you haven't come across Kotlin Multiplatform, this is a quote from Kevin Galligan. If you have been following Kotlin Multiplatform at all, you're probably familiar with Kevin and TouchLab, the sort of pioneers in this space. So this is probably a lot to unwrap, but there's sort of couple of key points here really to get across. And the first thing is this optionality. That differentiates Kotlin Multiplatform from other approaches. You can pull in as little or as much as you want at the start. And the recommendation is typically to start off small, pull in Kotlin Multiplatform for data model, some particular business logic or remote endpoint, as we're going to do today. And really, again, the other key point is that we're focusing here on non-UI logic on different platforms. So Kotlin Multiplatform is available on all these platforms. We're going to talk, obviously, about Android and iOS today. The project that this is going to be based on has other platforms included there. For example, I'll give a link to that later in terms of just if you want to go on GitHub and check it out. We have watchOS, macOS, Jvm, and Kotlin.js. So, and then the other thing to point out again, just to explain, I guess, if you've been following Kotlin Multiplatform, you may have sort of seen this Kotlin Multiplatform mobile announcement by JetBrains in the last couple of months. This has sort of been really mostly a rebranding that JetBrains have done, and really laser focusing in on, I guess, where the key area where multiplatform is sort of where the benefits can be gained from it, I think, which is obviously on mobile in terms of sharing code between Android and iOS. And along with the sort of, updated documentation and so forth, they've come up with a really nice Android Studio plugin that allows you to create a new Kotlin Multiplatform project from the start, to run and debug both your Android and iOS app from within Android Studio. So definitely recommend looking into that. So declarative UI. I don't know if folks have saw the previous talk from Manuel. You probably have at least an idea in terms of what Jetpack Compose is. It's a trend, I guess, we've seen in general across the industry. If people were using Flutter before, maybe React on the web, and now with sort of SwiftUI and Jetpack Compose, we're sort of converging on this approach in the industry of using declarative UIs. And the best sort of description, I guess, the best way of succinctly describing it is, it's sort of the what versus how. Declarative UI describes or declares what your UI should look like in a particular state. And state is important in this concept here. And any change in the state then will be reflected automatically in the UI. Manuel would mention that in the previous talk, where you hear this term in recomposition. There's a sort of an optimized recomposition of your UI that takes place when state changes. And this is a quote from Leland Richardson, I guess, who's one of the key architects on Google. This idea: state flows down via parameters to other composable functions. State changes flow up via callbacks observed data. And again, at least in the case of Compose, we're talking about, when we say functions, we're talking about standard Kotlin functions that are annotated with this composable notation. In SwiftUI, we'll see it's a struct. It's a Swift struct that we're using, but very similar. And hopefully that's the other thing I want to get across in this talk, is that when you look at the SwiftUI code and you look at the Compose code, you'll see, the slightly different words here and there, different sort of terminology, but the key concepts are very similar. And just a little bit of background, Jetpack Compose was announced at Google I/O in 2019. It's alpha release right now. It's available in Android Studio 4.2 Canary releases. SwiftUI was announced a couple of weeks later, actually, at WWDC in 2019, but it was at a more advanced stage at that point. It was available in Xcode beta that evening to download. And it's been available in production versions of Xcode for a while now, and there's production applications out there that are using SwiftUI. So just briefly, this is the project that we're going to basically talk on today, People in Space. Just mentioned here because, if you want to sort of maybe afterwards try it out, as I said, it covers a number of other platforms which may or may not interest you. But we're going to base out, depending on how much time we have, or how things go. It's sort of like an agile project. We're going to have, I guess, some core functionality we're going to try and build, and we're going to have some stretch goals maybe. But again, if we don't get to cover everything, at least if you can hopefully download this and try it out. And this is the sort of the official Kotlin Multiplatform mobile docs. This also has a link to this project as well. So the People in Space project was designed sort of what I described as being optimally minimal. It was designed really as a very small project to sort of get across the key concepts of a multi-platform project and see all the moving parts. And when I was coming up with that, or when I was sort of thinking about that, I came across this endpoint, and it was sort of seemed very fitting, I guess, for the type of project it was. This is a sort of a very minimal endpoint, and it simply returns the list of people in space. And that's the endpoint we're going to use today. So this is the sort of high-level architecture. Again, the multi-platform code obviously is below the line. We're going to create a basic repository, a class that represents our remote endpoint. We're using a Kotlin library called Ktor to connect to the endpoint, and our sort of data model. And we may not get a chance to cover it today, but if you're adding persistence, then we typically have something like SQLite, which allows you to persist in a multi-platform way. iOS and Android both use sort of SQLite databases. So SQLite is a multi-platform library that runs on those platforms and other platforms as well. And then obviously, on Android and iOS, we're using, the Jetpack Compose and a standard Android architecture view model on Android. We're using SwiftUI and something akin to a view model on iOS. Okay, so let's start coding. Okay, so this is the project that we're starting with, and I sort of use this as sort of a segue to make a couple of points, I guess. If you are starting down the path of Kotlin Multiplatform, I definitely recommend starting with some sort of predefined, pre-existing template or sample. You can create a new project now, as I mentioned, from that new plugin that's available in Android Studio. But if I look, if you look in Kotlin Lang and you look at people sort of starting off Kotlin Multiplatform, I think one of the key stumbling blocks really is getting up and running in terms of setting up your dependencies, setting up the right versions of, for example, and getting the right combination together. So People in Space is one example. If you're really only starting off for the very first time, I mentioned Touch Labs. They have an excellent sample called CampKit, which takes that little bit more advanced approach to some of these topics. So we're gonna start building out, as I said. This is just to mention as well. This is our common code. This is our common code module, and this is going to represent the shared code both for our Android. It's going to build a jar file which is consumed by our Android application. It's going to consume for iOS it's going to create rather a framework then, which is going to be consumed in our Xcode project, which we'll see in a moment. But all the code we write here is multi-platform, and at least within this common source tree within the common module. One of the things we'll mention at some point, in the talk is the ability Kotlin Multiplatform has to allow you to override effectively in a platform-specific way. If you're using SQLite, like I mentioned, the way you create the DB is platform-specific. So we'll use what's described as this expect actual notation. We'll write our common code. We'll expect a certain method to exist. And then in the various platform-specific source trees, we'll provide the actual implementation that satisfies that particular implementation. Okay, so let's start writing some code. So this is our People in Space API. Now, I should mention, by the way, I'm not going to hopefully put you through watching me mistype a lot of code. So what I've done in the sort of interests of also in terms of time as well, I've created a number of live templates for Android Studio and code snippets on Xcode, and I'll be using those. But as I'm bringing them in, I'll explain what I'm doing and often use those as obviously a hook to sort of get across certain sort of key points. So the first thing I want to do here is, this as shown above here, we have this is the JSON that we're getting back from this remote endpoint. So what we typically have in Kotlin is we'll have a set of data classes. And these are the data classes that map to that JSON that we're getting back. And we're using Kotlin X serialization, which is a sort of another JetBrains library that allows us, a very nice library that allows you to deserialize this JSON into these data classes. And we're going to use Ktor, and Ktor then we're going to configure Ktor to use that library. So this is the URL we're going to hit, the one mentioned above. And we're going to use the Ktor's HTTP client library. Excuse me. And this is a nice library. Ktor in general takes this very sort of Kotlin DSL type approach. If you know, there's a Ktor implementation on the server as well, and you'll see a very similar approach taken there, where you declare a client that you're going to use, and then you install certain features. So in this case here, we're declaring, or we're installing features that tell it that we want to use the Kotlin X serializer to deserialize the JSON we're getting back, and obviously a logger as well. And then we're going to add a method then to retrieve the people from this endpoint. And again, this is very basic, and we're sort of skipping over, obviously, error checking and a few other things we'd normally do here, but just again, to sort of get across the key concepts here. So we've written our very sophisticated remote endpoint class here, and we're going to implement an even more, or I should say, even less verbose repository class. So, in typical architecture here, we would have a repository, or you might have a use case layer in more involved applications. But in this case here, the layer that we're exposing to our Android and iOS client is this repository. And this repository is going to wrap around our remote endpoint requests, and typically would also manage persistence. Typically in an Android or in a mobile client, we would persist data locally, or you would take data from a remote endpoint, persist it to the database, and drive your UI, for example, from the database. So in this case here, we're adding a single. We'll build this out a little bit more as the talk goes on, but we're building for now just a simple method that wraps around the API method that we added in the people in space API. Excuse me. And a few things to note here. So we're using Kotlin 1.4 was released relatively recently. And one of the nice features that Kotlin 1.4 has is now the ability to call suspend functions directly from your Objective-C or Swift code. So in this case, this fetch people is going to be the API that we directly call, as we've seen in a little while from our Swift and SwiftUI code. Other thing just to mention here is that we're using Coin. It's a dependency injection framework. It supports multi-platform as well, which is quite nice. And we're injecting this dependency to the people in space API. So that's our common code, such as it is. So if we go to our Android module now, we're using sort of standard Android architecture components, for example. So we have a view model here. And again, if you've done Android development, you're probably familiar with sort of the architecture components and the Android view model, sort of providing sort of life cycle aware and all the various other features that it provides. And again, we sort of have a pre-prepared view model here, and we've already sort of injected in this people in space repository. This is the people in space repository that's coming from our shared Kotlin Multiplatform code. Another thing to note here is that we're using Mutable Stateflow. This is, again, maybe you're typically using mutable live data today. There's a sort of I guess a migration that I think is happening towards using Mutable Stateflow in a case like this. And we're using it in this example here. So again, in the Android view model case here, we have a pre-discussed. I'm not too sure how familiar people are with view models. Rather with coroutines. But Kotlin provides this mechanism where you can do sort of asynchronous method calls and so forth. And the Android view model provides this very nice view model scope, this implicit scope that we can use to call suspend functions from. So we're going to the value here. This is one of the rare enough cases, I think, where you're going to have to watch me type some code. And there we go. So that's our, I'm probably overly going to use the word minimal today, but this is our sort of our minimal view model again. On startup, we call into the repository that we created, we return back the people in space, and we set it against this value. Now our activity. So we're, again, sort of somewhat pre-prepared. And again, I'm sort of injecting in the view model using Coin again into the activity here. if you've seen manuals talk before, you would have seen, for example, that there's an extension function called set content, where instead of the normal setting out your XML layout files, for example, or if you were using fragments, you use the set content, and this is where we start to use Jetpack Compose. So I'm going to start by creating a composable function. So what we want to do here is we want to render in our UI a list of the people in space, and for each of those people, these astronauts, we're going to show their name and the craft. And this is what a Jetpack composable function looks like. In this case here, we have these sort of primitives, I guess you could call them, like row, column, text, very sort of readable. We don't have external XML layout files. Everything we're doing with the UI, we're doing in one place here. And then if I do the main layout, then excuse me, we're a few things I'll just go through these in a little bit of more detail, but again, it's that same sort of notation. Again, a composable function. We're passing in the view model. In this case here, we're going to convert that. We're going to convert the people in space from the view model into this people state. So again, I mentioned state was a key part of Jetpack Compose. And again, Manuel mentions the number of extension functions that Jetpack Compose provides. And one of them is collect a state here. So we're taking that mutable stateflow and we're converting it into a state then. And the idea of that state, and the key thing about that in Compose, is that anytime the state changes, the UI is recomposed, and it's recomposed in an optimal way. It doesn't sort of re-render everything. It's smart enough to re-render what it needs to render. We're using a theme which is kind of effectively derived from people in space, or sorry, rather the material themes. We're using Compose's scaffold, which is sort of just a way of creating a screen where you might have an application bar, some body, or maybe a bottom navigation. In this case here, we have a very simple top app bar. And then our body, again, you would have seen this example in the previous talk, where instead of, and I think that's always one of the great comparisons in Jetpack Compose, if you're used to using Recycler View, just how easy it is to create a list like that in Compose. We're using this lazy column 4. And we're using the items, this people in state value that is coming from our view model. And then, for each person in that list, we're passing that down, and that's the thing about Compose. You have a hierarchy of composable functions, and we're passing that down then to the person view. And then simply, in our set content, then we're just going to call main layout. And that's it. That's our, with no further ado, let's try and run that. And just to show this is real, the fact that we're waiting for the build to take place. So we're, while we're waiting for this, so hopefully this will run. We'll then move over to our Xcode project and do something very similar there. We're going to build out the view model. We'll build out the SwiftUI code. Oh, here we go. Okay, and this is the very long list of people in space. It's actually a lot longer than it used to be. A few days ago, 3 new astronauts arrived at the International Space Station. So I had to do some sort of quick sanity testing to make sure everything was working okay. Okay, so that's great. So we have our really basic, we'll enhance this a little bit in a little while, but this is our basic Android application running with shared code. We have our people in space API that provides this very basic API endpoint. We have our repository which wraps around right now. We have our view model which calls a suspend function, sets this state. We have our activity then, which uses Compose and renders the UI. Okay, so let's move over to our iOS Xcode. There's always some gotcha here. Hold on a second now. For some reason, Xcode isn't opening up for me. Okay, interesting. Maybe it's beside if I minimize this, maybe. Okay. This is interesting. It's shown here at the bottom, but it's not. Let me minimize that. I'm going to minimize everything in the hope. Here we go. Okay, for some reason I wasn't able to go over to it. Okay, so hopefully you can see Xcode here. Not sure if anyone, given all the sort of minimizing and changing of windows, if anyone's able to confirm that they can see Xcode, that would be great. So in a very similar way to our Android client, we're going to create a view model here, and I'm using Xcode code snippets here to insert certain pieces of code here. And this is our Swift. I'm not too sure how much people have seen Swift before, but this is the other element of this. Swift is very readable. You know, Swift and Kotlin are very similar to each other, and I think if you know one, it's very easy to read the other. We're doing something very similar here to what we were doing in our Android view model. We have this people in space repository, which is actually, you know, an important point to mention here. We're importing this common here, which represents the framework that's generated from that common module in our Xcode project, in our Gradle project. And we have assignment here, which maps to that same data class that we mentioned. And we have a method here, fetch people, which calls us the suspend function. Another thing to note here is that obviously the approach to, error handling and exception handling in Kotlin and Swift is different. So what, you know, in our Android Studio project, we declared a method called fetch people, and we said it throw an exception. That exception will map to this error in the callback here. So what Kotlin and Kotlin native provides under the hood then is sort of effectively a wrapper around that suspend function that allows us then to call it in Swift, provide this Lambda, get back the result if there's a result, get back the error if there's an exception. And we're going to obviously set, similar to the way we were setting our people into our mutable stateflow in our Android view model, we're going to set this people to this publish. This is a combined framework that iOS provides to, again, this very similar idea to so that UIs can observe data and observe the updating of that data. And then in our Swift UI code, then we're going to do something very similar to, we're going to have a person view, which is very similar to our person view in our Jetpack Compose code. Obviously different structure. We had a composable, we had rather a Kotlin function in Jetpack Compose. We have a Swift struct in this case here. We're passing in this, you know, URL and person, just like we were passing in Jetpack Compose. And instead of row and column, we have HStack and VStack, and we have text. And obviously some differences in how attributes are set up and how modifiers are defined and so forth. But again, very similar, I think. And then similarly to our main layout, we're going to have our content view here. And this is a little bit more involved in terms of just, you know, to unpack in terms of everything going on here, but very similar. We're using our view model. We have a navigation view, and this is the list. This is analogous then to our lazy column 4 that we had in Jetpack Compose. And in exactly the same way, then we're iterating through that list, and we're passing down person view. And similarly, we're going to run this. Just checking how we're doing for time. Okay. I like to think these sort of longer build times get across the fact that this is live. But just while that is building, as I said, just to mention, you know, this is based on the people in space repo that is in GitHub. There's a Mac OS client in there as well, for example, if you want to try that out, it takes advantage of sort of the greater screen real estate that we have. And there's a web and a Jvm application there as well. And hopefully we should see actually as that UI is, or as the Xcode simulator is sort of loading up, we should see, yeah. So this is exactly the same list. This is the same list we saw obviously in our Android Studio and in our Android emulator. I'm using the same shared code. So if I go back to, or if I hopefully go back to Xcode or to Android Studio again, we're going to make a couple more changes just to sort of just demonstrate a couple of key points. You know, our repository here is right now. What I have in the GitHub repo, and what maybe we'd like to add here is maybe show a picture for each astronaut. Now, sorry, get my code snippets the right way. So here we're going to add one more method to our repository, and again, this method isn't immediately going to be available then to our iOS and Android clients. We're going to call it an API to get the person image. Now there isn't actually an endpoint to get this, so somewhat of a hack. For now, I have a sort of a static list of images, or URLs rather, for the different astronauts. But the good thing, at least, is this is centralized in this one place. It's added to the shared code, and it's immediately available then to the Android UI and to the SwiftUI. And so we're going to add in another method to our view model on Android to get the image. And then in our SwiftUI code, we're going to start using that here to get the people in space, to get the person image URL. And now in our row and column here, we're going to add in a element here, which is a coil. So again, if you've follow, or if you've tried out Jetpack Compose, you're probably familiar with the Chris Baines, I think it's accompanied, if that's the right word for the library, provides a couple of other value add capabilities along with Compose. And one of them is coil image, which allows loading up and rendering an image from a URL. So if we run that, okay, great. And now we can see the images. It looks a little bit nicer. And if we move over now to Xcode, again, we go into our view model, and we add another method in here to call that method. And again, so that get person image method that we added. Sorry, now I'm just wondering why. Oh yeah, okay. So this is giving an error right now because we haven't rebuilt the framework yet. That'll get resolved when we build it. So this is calling, just to emphasize again, this is repository. This is our people in space repository mapping to that Kotlin class that we've been changing. This get person image is this new method that we've added in our SwiftUI code in a very similar way to the Jetpack Compose. We're going to comment out this call here, and instead of that coil image, we have an image view, sort of a pre-prepared. We have a pre-prepared sort of wrapper around a control, effectively SwiftUI control, that will render the image. And again, if I run that, excuse me. Hopefully building, yeah, okay. And there we go. That's our iOS client. Again, very similar to what we had on Android. And just to emphasize, I mean, that if I go to the Android to the Xcode, or to I'm sort of multitasking too many things here. But if I go back to Android Studio again, and into our repository, even albeit this is a sort of a somewhat hacked implementation of getting the URL. For now, we sort of have to hard code that list. But a key point thing to get across is that we've done that in that one place. And if and when we have an endpoint that we can use or an alternative approach, we update this code, and that's immediately available. Then the UI code doesn't need to change. Let's see, conscious of time. Okay, so like I said, I was treating this somewhat like an agile project where we have sort of an MVP to some extent and a couple of stretch goals. So I think I'm good for time. I'm going to relatively quickly add in some persistence code. We're using SQLite, which is, I said, a multi-platform library. Now, again, this is going to bring in quite a bit of code, but I'll explain what that is in a moment. Okay, sorry, I am going to just realized something which I'm going to rectify very quickly. Sorry, while I have you here. Just realized that in my code snippets, I left out some important. Okay, here we go. Hopefully we've recovered that. So what we're pulling in here is SQLite, and what that provides the capability, obviously, then, you know, as we're doing in this case here, how we've changed the code is that we're retrieving the data from this fetch and store people. We're retrieving the data from the remote endpoint like we did before, but now we're persisting it in the database. And we've added this get people as flow method that I'm still not quite sure why it's giving me. Oh, here we go. Okay, sorry, it took a little while to update. We have this fetch and store people where we get the data from remote endpoint, we store it in the database, and now we have this SQLite provides a mechanism where you can observe, similar if you're using Room, for example, on Android, where you can observe changes to the database as a flow. And this allows us to show one other thing as well, which is this create DB. Within our common code, we have this create DB, which creates a database, but the way that's implemented then on different platforms differs. So we have an actual implementation for iOS, which uses native SQLite driver. And we have similarly, we have, you know, implementations for the other platforms as well. So having added this database code to our repository, now we can go back to our view model, for example. And instead of, hopefully I have right code snippet here. Sorry, bear with me again. Yeah, it should be collect. Okay. Sure why that's not coming up here. Again, I'm going to cheat a little bit, and I'm going to go over to my existing project here. I'm going to copy that over. And now, you know, you see the difference here, for example, key difference here. Instead of calling this sort of one-shot suspend function that gets back our data, we're now calling this people in flow, which we collect the data. I'm not too sure if people have used flow much, but this is sort of a mechanism where you can observe stream of data, for example. And now any changes in the database then would be reflected and the UI would be updated accordingly. Whereas previously, obviously, what we had before was a static one-shot list. So that's kind of covered, I guess, the main parts of what I wanted to show. As I said, the repository has a number of other projects. I'm just going to very briefly move over. I have a Mac project here. And if I run that, you see this is in the version of this project in GitHub. There's also another endpoint which returns the position of the International Space Station. And this is taking advantage of the extra screen state we obviously have on macOS, and it's showing a map as that changes. That's polling for that position every now and then. And then the list of people then is the same list of people that we were obviously showing from the other endpoint. And then just other thing just to briefly show is that the project also has a sort of Jvm Back End. I have sort of a bit paranoid. I have a dummy sort of back-end server running here, just in case the endpoints stop working for some reason during the talk, which serves up sort of dummy versions of that data if necessary. And that's using JVM. It's using sort of same shared code. And similarly, there's a Kotlin JS project here as well, again, that utilizes that same shared code. Hopefully, a few little glitches here and there, but hopefully that gets across. As I said, you know, trying to get across really just the power of Kotlin Multiplatform, the power of Declarative UI, why I think they're a really compelling combination together. The fact that, you know, as an Android, as an iOS developer, Swift and Kotlin are very similar, SwiftUI and Compose are very similar, and how we're starting to converge on these, which, you know, when we talk about alignment across mobile platforms, Android and iOS, you know, I think these are powerful sort of developments. I think that are steadily making that easier, and it's going to continue to make that easier.